Hi 11, hope you had a good weekend. I posted this on Google Classroom, but tomorrow we will be finally having our first Adobe Connect lesson online. So please make sure Adobe Connect is downloaded on your device and working on your device before our lesson tomorrow. Okay, and it'll be starting at 10:55 a.m. Okay, it'll be great if you have access to a mic and a webcam, but it's also okay if you don't have access to one. Alright, so today's lesson is going to be a review on capacity. So far in this topic, we've been talking about volume of 3D objects. And remember, volume is just the amount of space a 3D shape takes up. Now, capacity is also a property of a 3D object, but not all 3D objects have a capacity because by definition, it's the amount of liquid a container can hold. So the 3D object must be a container to have a capacity. The metric unit for capacity is liters. Okay, and by definition, a container with the volume 1 cubic centimeter will hold 1 milliliter of liquid. So a few examples that you will see around you could be a can of Coke or a bottle of milk or even your hand sanitizer. These are all containers that can hold liquid, and at the same time they have a volume because they occupy space. Now today we'll be looking mainly at converting these units, and to do that we need to remember our converting factors. So remember, when we're converting from cubic meters to cubic centimeters, we can derive this factor by thinking about how many centimeters there are in a meter. There's 100, but because we are cubing these units, we'll be cubing the factor as well. The same goes for going from cubic centimeters to cubic millimeters. Okay, there's 10 millimeters in a centimeter, and so we would need to cube that number as well. And remember, when we go backwards, we are dividing those factors we found at the top. Okay, now let's have a look at the capacity unit. The basic unit is a liter, but if we have milliliter, we have a thousandth of a liter. And so to go from the amount of liters to the amount of milliliters, we're multiplying by 1,000. The same goes for when we go from kiloliters to liters, we multiply by 1,000. And the same goes for going from megaliters to kiloliters. We are multiplying by 1,000. And likewise, for when we go backwards, we are dividing by the factors that we found at the top. Okay, so these are conversion between the same type of units, but now we need to be able to convert from capacity units to volume units and vice versa. We can do that by looking at the conversion rate that I have mentioned above. Now I'm going to derive a few results from this so we can do some easy calculations. So the first is when we have 1,000 cubic centimeters. And so 1,000 cubic centimeters, okay, would be 1,000 milliliters, okay? And we know what 1,000 milliliters is. It's 1 liter. So we can say 1,000 cubic centimeters is 1 liter. What if we have units in cubic meters? Let's have a look at how much capacity there is in a cubic meter. So if we have 1 cubic meter, okay, according to our conversion rate up here, it's equivalent to 100 to the power of 3 cubic centimeters. So that it's 1 with 6 zeros, 1 million cubic centimeters. Okay, and we know that's equivalent to the same number of milliliters, and that's equivalent to 1,000 liter or 1 kiloliter. All right, so if we have units in cubic meters, okay, we would have the same number of kiloliters. So that's another useful result to know. Okay, so let's think about that as we answer a few questions involving containers. So our first example is a fish tank, okay, and it's filled with water. And we're going to figure out firstly its volume so that we can find out its capacity. All right, so the volume, okay, of this container is a volume of a rectangular prism. Okay, we know the formula for that. It's the area at the bottom times the depth. Okay, so A times H. All right, the area is 70 times 40 at the bottom, multiplied by 30, which is the depth of the fish tank, and that gives us 84,000 cubic centimeters. And we can now use that to calculate the capacity of that fish tank. And so, as we've mentioned above, the capacity is the same number of mils as the number of cubic centimeters. So that's 84,000 milliliters. And we can write that in a more appropriate form with less zeros. Okay, that'll be 84 liters. It's requiring us to convert from cubic meters specifically to milliliters. Right? So let's think about our result from above. The number of cubic meters is the same as the number of kiloliters. So this is equivalent to 3.12 kiloliters. Okay? And to convert to milliliters, we go through our conversions from above. So to go from kiloliters, we need to multiply by 1,000. And then 1,000 again to get to the milliliter. All right, so it'll be 3.12 times 1,000 times 1,000. Okay, and that should give us 3,120,000 milliliters. Now you might be given a question where you're given the dimensions of your solid. And when you're calculating the capacity of that solid, there are two approaches that you can take. The first is finding the volume in cubic millimeters first, and then converting that to cubic centimeters, and then converting that to milliliters. But there's a quicker way with less chance of making a mistake, and that is by converting these lengths to centimeters first, and then using that to calculate the volume in cubic centimeters, and then we can easily convert that to milliliters. And so here, okay, we have a cube with dimensions 90 by 90 by 90 millimeters, which is the same as 9 centimeters by 9 centimeters and 9 centimeters. So the volume is 9 times 9 times 9, which is 729 cubic centimeters, and we know that's the same number of milliliters in capacity. And that's our answer. Let's have a look at a few problem-solving questions. So the first one here is a container is in the shape of a triangular prism with a capacity of 12 liters. We're given the area of the base, but we want to find out the depth or the height of the prism. So we know the volume formula for a prism is area times the height. Okay, we know the area is 240 times h, and v is equal to that. So we need to know v to be able to find h in this equation. And we can do that by looking at the capacity here. That's the hint, 12 liters. We can convert that to its volume unit. And so remember, 12 liters is equivalent to 12,000 milliliters, which is equivalent to the same number of cubic centimeters, right? Now, area unit is in cubic centimeters, all right? Sorry, in square centimeters, and so that will be the value that we'll be substituting in for V. So that's 12,000 is equal to 240H, right? And to make H the subject, we just divide both sides by 240, okay, which would give us 50 centimeters. So that's our answer to that question. Now, the next question we have here is we have 12.5 hectares of land, which is covered by water to a depth of 30 centimeters. And the question is, how many kiloliters of water is covering the land? All right. So for this question, I want you to have a go on your own and write down your answer in your workbook and upload that on Google Classroom for me. And we'll go through the answers tomorrow, but I'll help you get started with the question. Okay, we have some area of land. Okay, we can assume that the water arises above the area to create some volume of water that looks like a prism. Okay, and remember, the volume of a prism is given by A times H. Okay, so I want you to use the information given to you, the area, the depth or the height, to find out the amount of kiloliters of water covering that land. Okay,